Now this video provides you a short introduction into multi-factor models. So in general, factor models aim to characterize variations in systematic risk by a set of factors. So remember from the CAPM or the single index model that an asset's return variance is made up of two components, a systematic component and an asset-specific component. The systematic component can be driven by a set of factors, which we here call capital F. Note, F has an expected value of 0 because it measures new information about the macroeconomy. So F captures essentially the deviation of the common factor from its expected value. To simplify the exposition in that video, we treat F as a single factor. Now, a single factor model would therefore postulate the following return dynamic for asset I, where the expectation of Ri is denoted as E of Ri, beta I is firm I's return sensitivity to the single common risk factor F. And importantly here, the firm-specific return component epsilon I has the following dynamics. Its expectation is 0, its covariance with F is 0, and the covariance with epsilon j is also 0. So here these restrictions written in terms of expectation say the following. The first restriction on epsilon I says that it has a 0 mean return innovation. The second restriction says that epsilon I is uncorrelated with the common risk factor. And the last restriction highlights that it's truly an asset-specific return innovation. Now the next more general linear factor model is a two-factor model. As an example, consider that we would like to test whether business cycle risk and interest rate risk is part of the economy's systematic risk factor. So we would say that GDP and IR capture unexpected innovations to GDP growth and unexpected innovations to the 1-month nominal interest rate. The respective two-factor model for asset I would read as follows. Note that both beta coefficients in that last equation are also called factor sensitivities. Notice that a multi-factor model for asset returns induces a multi-factor security market line. That resembles that an asset's expected risk premium is made up of the expected risk premiums of the different factors times the factor sensitivities. Equation-wise, that means we can write the expected return of an asset within a linear multi-factor model as being equal to the risk-free rate plus beta I GDP times the expected risk premium for GDP plus beta I IR times the expected risk premium of IR, where ERP GDP stands for the expected holding period premium for a 1-unit exposure to GDP risk, and ERP IR is the expected holding period premium for a 1-unit exposure to interest rate risk. Again, the last equation is just one example of a two-factor model. And later in the course, we're going to address explicitly how to estimate the expected factor risk premiums.